oh, they pulled the plug. And actually, really, even NASA say they accidentally unplugged the telemetry. It was a human error at their end. They unplugged the telemetry. So NASA wasted $1 billion spacecraft, lost it, and never saw any data from that spacecraft. Now, people speculate that, as people do, that okay, we've got $1 billion spacecraft. They have NASA do the space programs, we know it, but obviously there's other interests who can control. Military interests, for example. And it's entirely possible that spacecraft was resurrected and did actually go into orbit around Mars and was still used. But to this day, we don't know. As far as we know, it's just lost. And it was just interesting because people were trying to get more accountability from the space agency that we're paying for. That's all that was happening.
Well, the Americans are paying for it.
Yeah, the Americans, they were paying for it. Yeah, they were lobbying Congress, not us.
Our effort to land on Mars was, it was going to bounce, wasn't it?
Oh, the Beagle.
The Beagle.
Yeah, that was an interesting... Yeah, because that Beagle was carried... Was it 90? I forget what that was.
It wasn't that long ago, was it?
Yeah, because it was supposed to be there about the same time as the Mars Exploration Rovers.
I've met the professor who created that mission.
Yeah,
in fact, he signed a book for me. Yes, well,
Yeah.
I think... Do you think perhaps he was sabotaged because he was going to be the first to prove life was on Mars?
Yeah, of all the landers that were sent... Well, the Viking mission... the Viking 2 lander, the second lander from the Viking mission, was the only one with the chemistry experiments on. And the label release experiment tested positive for life. As you know, everyone has probably heard about this. But they basically decided that, okay, because the other two tested negative, the other two tests, that it obviously must have been a false positive. So back in the 70s, we had a positive test for life. And this particular lander from the European Space Agency, in that case, had an instrument which would have been key to actually identifying biological materials. And obviously, unfortunately, the lander was lost. It just crashed into the planet. The understanding is that basically the airbags or the canopy did deploy properly, hence it just crashed. But who knows?
Who knows?
Why? Anyway,
okay, let's have a look at the Pathfinder images then, because these are the more recent images. This is where we have 2 Mars rovers.
Actually, the Pathfinder mission was basically a trial run for the current... Currently, we've got... Still to this day, we have the 2004 mission with still 2 rovers running around.
Okay.
But back in 1997, they had the trial run of trying to send a robot, basically, to Mars. And it was a feasibility study to see if they could actually do it technically. And so they managed to get a lander onto the planet with a little rover called Sojourner, which then was able to roll off the landing pad, drive up to a rock and do some kind of drilling into a rock. It was a feasibility study for the mission that was due for 2004, and it was successful.
Well, let's look at number 4, shall we?
Okay. Have we got image number 4?
There you go.
Here we go. So this is this image shows you the actual robot called Sojourner, which is sitting next to the rock, ready to investigate it. It didn't have much of a range. It was basically a feasibility study, as I said, but it was still there's still some good experiments in there they were doing. But fundamentally, it was basically to see if they could actually control a robot around the planet.
Okay, and what about the colour of the sky here?
Yeah, this is 1997. Remember, this is like just over 20 years later, after the Viking missions, and the sky is now like a kind of reddish tint, slight pinkish reddish tint to it, which is kind of obviously we weren't expecting that. We'd seen the Viking photographs and we'd thought, okay, Mars had a blue sky. Anyway, we've got the next image, which we'll maybe show.
4C. Can we have 4C?
Again, so a photograph taken at a different time, showing a different direction. Again, a very similar image, very reddish rock. The rocks are looking a lot redder and brown, deeper redder than they were before. The sky is looking kind of a pinkish red hue, which is kind of interesting because these are typical of the photographs that were returned from the Pathfinder mission in 1997.
Okay, and then we get on to the 2004 mission.
Yeah, so if we back in 2004, the NASA sent basically 2 probes aboard. I forget which orbiter sent them actually, but the Mars Exploration Rover program took 2 rovers called Spirit and Opportunity, both of which successfully landed on the planet Mars. I think it was January 2009. They were expected to last for...
2009?
2004, sorry. 2004. Yeah. They were expected to have a lifetime of probably about 6 months each. They had a warranty for 6 months.
Warranty?
This is back in 2004.
Take them back to the dealership if they don't work.
Yeah, what are you going to do?
Okay, I think we're finished with that picture now, thank you.
Yeah, so back in 2004, obviously we've got these 2 rovers, and they lasted... Well, they're still running to the present day. They're still taking images. And so they've lasted like 12 times the duration they expected them to, so they've been a huge success, and they've captured like probably millions of bytes of data as well. That doesn't really mean anything. If you compare like the missions from the Mariner missions from the early 70s, well, the first mission, successful mission, which I think was an orbit, a flyby actually, sent 21 images back. If you look at the number of images, you can go to the NASA website, you'll see thousands of images in there, and it adds to them daily. So we're collecting a hell of a lot of data.
Okay, let's look at some of these images then from the 2004 mission. This is with the 2 rovers, and let's look at number 5, please. Image 5. Oh, it's a bit dark, isn't it?
Yeah, you can kind of see. Yeah, it's quite a dark image really, but this is from the rover called Spirit. And you can see its tire tracks, it's driven up, and it's looking back to where it's been, and it's looking at some collection of rocks on the right hand side.
Okay, let's go number 6.
And yeah, this is a brighter image, but again, what you're seeing is this is actually one of the rovers still on its landing pad. So you see the kind of the white material on the right hand side. That's because it's still sat on its landing pad. But what you see is in the distance. You see got like you can see like the glow from the sun, but you've still got a reddish hue in the sky.
Reddish tinge, yeah.
You've got very red and brown, reddish brown rocks.
Okay, so why are these images looking so red all of a sudden? Why are we being sold the idea that Mars is very alien when earlier images looked a bit like home? It looked like I don't know, Nevada or somewhere.
Well, I don't know. In one sense, it could be that the reason, the rationale for looking at images like this, and we understand that Mars is the red planet after all, so maybe we're expecting red images. Maybe that's what happened. Maybe we got it wrong back in the 70s somehow. But
well, there's one way of knowing, though, isn't there? So if we look at number 7, image 7.
Yeah. One thing they actually did on both the Viking missions and the current missions, and actually the Pathfinder mission as well, they have these things called the colour calibration targets, which look like little joysticks, computer joysticks on the top of the rover. And this particular image has got a cutout and a zoomed, so you can it's zoomed in on the actual calibration target. So you'll see like a round disc with a black joystick type thing. And at each corner you have a different colour. On this particular image you'll see on the bottom right you've got a bright red colour. The top left and the top right are showing a kind of brown colour. And I can't quite make out the colour on the bottom left. It looks kind of dark to me. I can't really make it out on this particular image.
Okay.
Well, this poses a problem because this target was designed solely for the purpose. Well, not solely for the purpose. It measures light intensity, but it also allows you to calibrate the colours correctly. Now, for some reason, the two colours at the top are actually showing us the same colour, so something's obviously wrong. Now, if we're just going to look at the next image, we'll see what it should look like, what it looks like on the Earth.
Okay, number 8. This
is what it looks like on the Earth. So on the bottom right of this image, this is you'll see it says 2 worlds and 1 sun. Obviously, because it's our neighbouring planet. It's our next door neighbour is Mars.
Yeah, it's just a little bit further from the sun, isn't it?
Yeah, it's a bit further away.
But it's in the Goldilocks zone, isn't it?
It's
not too cold and not too hot.
Still, yeah, it's in the trust. Yeah. So what this image shows is basically the calibration target. On the bottom right, you have a blue target. And on the left, to memory, it's actually green, but I can't see this on this monitor, but it's a green target.
So we've got a rubbish monitor to look at it on.
Top left. Top left under the guy's finger is actually green.
It's green.
I think red is the bottom left, or yellow is the top right.
Hopefully you're getting the right colours at home.
With these last few lights, I can't quite see the monitor, but so basically, this was designed to use so that you could actually calibrate the photographs properly. Now, if we can go back to the previous image, which was
go back to number 7.
You see that the image that was actually blue in the one in the laboratory is now bright red on Mars. Well,
so they've made anything blue go red.
Well, yeah. I mean, the thing is, it shows that it hasn't been calibrated properly. Well, people have argued that the reason this shows up as red is because the Martian sky is red, therefore it's giving off lots of red light, which is saturating the thing, so everything glows red. Well, the problem with that is that when you have something that's blue, a material that is blue absorbs light and basically re-emits blue light. If all you do is shine a red light on it, it will never absorb the red light and re-emit red light. Blue colour materials just don't do that.
Blue will stay blue.
Yeah. The only thing that will emit red light is something that will emit red light, which blue doesn't do. So there's something really wrong with it. The image has simply not been calibrated. They were showing false colour images, effectively.
But this is just insane. I mean, they can't possibly have made these mistakes by mistake, can they? Because they've got the same access to these calibration. systems as,
Yeah, I mean,
as we have when we've
that's right.
found the right photographs.
There is a situation where they actually use more than red colour. But what we described as a situation where they use red, blue and green channels. The rovers also measure infrared light, so they have they measure the eyes and the cameras on the rovers measure four wavelengths of light: blue, green, red, and infrared. And sometimes what they'll do is substitute infrared for red. So they'll rather than use the red channel to show red